Join again. All right, recording started. Um, codelab link has been shared. I'm going to share this again and pin it because we want all of you to be on the codelab because we'll do a lot of copying. Yeah, Mohan has pinged it. Also pin it, Mohan, if you can. Thank you. Yeah, so the link is there in the chat. Please click that and go to the introduction part of the code lab. I want to walk you through what we're going to discuss today. So what we're going to discuss today is SQL only application, which is in place LLM. So what is in place LLM is a large language model application. So we are going to build a generative AI application, or rather LLM analytics or rather LLM insights application in place. In place means bringing generative AI closer to your data, where your data resides. Usually, where does your data reside? Don't tell me CSVs or Excels or anything of that sort, right? Or files or images. Of course, data is in different forms and different fashions and different formats. Ultimately, in this case, we are going to take into consideration two different formats of data, structured and unstructured, right? But the data is residing in database. Let's call it database in general. We can also call them as data warehouse if you're talking about analytics applications, right? Or data lake or anything that you may want to call it. In this case, we are going to take BigQuery. So why is it called in place? It's called in place because data resides in our data warehouse or database rather with application, which is BigQuery, and we are going to bring LLM right where the data resides. That's why it's called in place LLM, generative AI, where the data resides. Now, why there are two categories of data or formats or structures of data that we are looking at, structured and unstructured? The reason is there are multiple ways you can consume LLM on the data that you have in your database. BigQuery, for one, is the kind of data analytics or solution or the data warehouse which lets you store massive data in all kinds of formats like structured, semi-structured, and unstructured. Unstructured, you may be wondering, how will I store images in a database like BigQuery? So it allows you to store unstructured data also in a concept called external tables. It will, behind the scenes, store the images and all the objects that you want in cloud storage, and it'll store the metadata in BigQuery. But the advantage of doing this is you can query unified data in structured, semi-structured, and unstructured format together as if they all coexisted in the same database, and you can make insights or generative AI insights on the data that you have in a unified fashion. So that is the advantage of, rather the power of having different types of data and structures of data in one database. Now, enough of what BigQuery is capable of doing. We'll have to get started with the LLM application, right? So what we'll do is we'll store a big books related data, right? Bookshelf data, library data in BigQuery. Basically, the data that we will use for this application is coming from publicly available data set, which is there in BigQuery already. If you go to BigQuery and if you just surf the data that is available publicly, like it's called public BigQuery public data sets. There is so much available for you, which you can leverage to build your prototype applications, or in some cases you can use this to do a lot of research or build applications and see how the system is performing, or even take that to build your prototypes to other systems within the scope of Google Cloud, or whatever you're building, whatever applications you're building, you could use that data. So in this session today, we are going to one of our use cases is related to bookshelf data. We'll summarize the context of books that are already stored in the public data set in BigQuery. So we'll use that data. What we'll do on top of that is we'll build generative insights or generative AI insights on the book data that we have. So what kind of data? We'll see that in a bit. All right. So how we are going to invoke generative AI that lives in models like Gemini, that is actually represented in models like Gemini or Text Bison, or different versions of Gemini model itself. How are we going to invoke that in BigQuery, right? So that is where there are two things. One is remote model invocation and remote function invocation. So for all those models that you want to use out of the box, so what do we mean by out of the box? So Gemini 1.0 Pro or Gemini 1.5 Pro. So these work in a way that are designed to work in a specific way out of the box without fine tuning it or without changing it. If you want to use it as it is for doing your generative insights, then you create a remote model in BigQuery that talks to that model in Vertex AI and applies that to your data, right? So that is what remote model is. Now, let's say you want to tweak that, you want to write your own function. I'm not talking about fine tuning yet. I'm just saying you want to write your own function, call that model, but on top of the model calling in that function, you want to do few other steps, right? You want to compare images, but then augment that information or do some RAG on top of that, or do some other integration to a third party application, and then fetch the result as part of the BigQuery function call. Then you cannot use a remote model as it is, because you're not just using Gemini out of the box, rather doing some additional functionality on top of that. So in that case, what you will do, you will write your own function in whatever platform you want. In this case, we are talking about cloud functions, right? And we'll expose that into in a REST endpoint, and you will call that endpoint in BigQuery as a remote function. So these are the two methods of invocation we are going to discuss today. Um, First one, you will do hands-on with me. Second one, I'll show you how to do. You can do it at your own time at some other point. Why it's not, why we are not doing it here? One, mainly because we want to be able to cover the first one comfortably and see how you're able to make remote procedure calls within BigQuery. The second one, if you remember, you have already done in the first two sessions of the season. So we wouldn't be spending so much time on that, but I will still show you how to do it. If you're able to tag along and continue to do that, feel free to do that. But all the steps are listed in the code lab. Step 5 is really important for you to complete the first part, which is invocation, and that is what you'll submit as results as well. Now, why is this called as remote model invocation or remote function implementation? Why is it remote? It is remote because you are calling, if you can see in this image right here, you're calling, this is your BigQuery data set, right? This is where your data resides. Now, Vertex AI is the suite of AI, ML, and generative AI models that lives in Google Cloud. So you're making BigQuery talk to Vertex AI in order to get that generative insights. So that is remotely invoking the model, right? That process is remotely invoking the model which resides in Vertex AI, even though in the bigger picture, they all live in Google Cloud. So that's why it's called remote model invocation. The reason the first option is called model is because you're directly calling the model without making any configurational changes in it. Not just configurational changes, but also you're not updating it. You're just using the model out of the box as it is. The second one method is called remote function implementation or remote function invocation, because on top of calling the model within your cloud function, you will do anything you want in it, right? After invoking the model. Or you may or may not even invoke the model. You're just writing your own function to do anything. You can use whatever model you want, which would be a bad decision because Gemini is awesome. But yeah, the whole point is you will expose that as a cloud function and deploy that in a remote endpoint and use that in BigQuery and call that as a function. Both of these will result in a similar fashion. You're just calling a stored procedure. It is similar to that, but behind the scenes, one is calling the model out of the box and the other one is calling a remote REST endpoint. So that is what it is. All right. So why we have chosen BigQuery for it? Of course, all of Google Cloud databases support integration with generative AI, or rather Vertex AI. So you can do a lot of analytics on top of that. But BigQuery is serverless. It's multi-cloud data warehouse. It can scale bytes to petabytes over seconds, right? Not even seconds. Like you could get a lot of compute and operations done when you're in a production billing system, not in the uh, trial billing account that we have. But typically, that's how scalable BigQuery is, right? And you can do analytics and you can bring in data of different formats and types together. All right. So I just wanted to give you the design decision of why we are doing it before we get started. Now let's get hands on. All right, so now we know what we're going to do. The first one is the bookshelf application. For the second one, which is a remote function, we will compare images. We'll compare a test image against a baseline image, and we'll ask Gemini to tell us whether they are similar or not. Okay, and in order to do that, we'll store the data in the external table in BigQuery, and we'll also trigger the query from within BigQuery itself, all using SQL queries. Okay, so I hope you are all set up with your projects and your credits and everything is ready. Show of thumbs, please. Ready for the hands-on? Okay. All right, so let's get started. So the console where you have your billing account and project and everything set, just make sure you click on the Google Cloud logo and you see the desired project, or rather the active project, or rather the project with an active billing account selected in the drop down. Right, so that is where we are going to get started. Now, the first thing to do is make sure you have all the services that we are going to use today. The APIs are enabled for those. So we are going to use BigQuery because obviously our data is going to be stored there. We're going to use BigQuery connection. Of course, because why? Why do we want BigQuery connection? Because we want BigQuery to talk to Vertex AI. In order to establish that remote communication, we have a concept called BigQuery connection, which we'll enable in a bit. And then we need Cloud Function, Cloud Run, Cloud Build, because Cloud Function behind the scenes operates on Cloud Run. And then we want to enable Vertex AI and then Cloud Storage APIs. Alternatively, just feel free to click this link and let's just enable the bare minimum ones for now. As in when you're doing the steps, you will identify that if it shows some error saying that the API is not enabled or something like that, you can always enable. Sometimes I miss out on telling you what APIs need to be enabled. That doesn't mean you can skip that. If something is not working, you have to first make sure the corresponding services API is enabled. So that is why I've listed everything here. In case you don't accidentally get that from the link, you can always search for the corresponding service in the console. Like right here, I'll go and search for BigQuery. The one that comes up that says Data Warehouse Analytics, click that. If it is the first time you're searching for BigQuery or opening BigQuery in your console, it will ask you to enable API. It will give you a prompt, pop-up, and will say enable API. Go ahead and click that button. It's as simple as that. Similarly, you can do for each item in the list. If not, you can also copy this link. This is right here. Copy this link if you're on a different tab and go to the tab where you have your console open, paste it there, and then hit enter. It will bring the APIs that you need to enable. In this case, it is enough if you enable BigQuery, BigQuery connection, and Vertex AI. These three, because we are going to do the first part now. Second part is there in the code lab. You can complete it at your own time. I will walk through that. You don't have to do it hands-on. You just do the first part hands-on. Okay, so these three you're about to enable. Go ahead and click enable. That's it. Once it's enabled, you should see the enable button in gray. Show of thumbs, how many of you got to complete this step? Okay, perfect. So moving on, please go to the code lab. Use the chat if you have questions. The second thing is we want to create BigQuery dataset. We discussed that we are going to use BigQuery's data. We decided that we are going to use the bookshelf data that is available in BigQuery public dataset. But can you edit the public dataset? Can you create tables in a public dataset? No. Why? Because public dataset is available publicly. You can read only from public data set. You cannot write a table in or make changes there. So we are going to create our own little data set just for the use case, for implementing this use case, and we'll extract the data from the public data set, the book table that we want, and we'll write it into the new data set that we'll create. Now, what is a data set? Just like in any database, when you're setting up the database, you'll create a new database and then create table inside the database. Similar to that, in BigQuery, dataset is equivalent to a database in any other database or data warehouse. So it's called as dataset in BigQuery. So let's go ahead and create the dataset that you will use for this implementation. And then we'll create the table. We'll create the external connection, and then we'll create the table and load the data. So how are we going to do that? Go to the Google Cloud Console. Once you enable the API, just click the Google Cloud logo, come out of it. Now search for BigQuery again. All right. So once you land on BigQuery, if you're already on BigQuery, great. You don't have to change much. You should be able to see something like this. On the right pane, you'll see Welcome to BigQuery Studio, the actual query studio, query editor. And on the middle pane, you'll see the Explorer pane. And on the left, the navigation menu. Don't worry about it. You can just push it back. All you need right now is the Explorer pane and the BigQuery Studio. All right. So once you see this, make sure you see the project name listed as the first project. In my case, my project name is Do It AI COK. Whatever your project name is, you should see here on top. Now there should be a vertical ellipsis adjacent to your project name. Go ahead and once you hover over it, it should say View Actions. Go ahead and click that ellipsis, and then the first action there is Create Dataset. Click Create Dataset and dataset ID. Go to the code lab and copy the dataset ID from the code lab. You can give whatever name you want for the dataset, but it's better if you copy, because there are a lot of cases in step 5 where you copy the DDLs and DML statements, rather the SQL statements. You don't want to make change each time. So just copy the dataset name. It says Gemini underscore BQ underscore FN. So copy that and paste it in your dataset ID, Gemini underscore BQ underscore FN. I think I probably already have it. I'm going to change it, but you don't have to. Okay. Maybe if I don't have it, I'll just create it. Just copy paste from the code lab, and location type, leave it as multi-region, leave it as multi-region US, right? Don't change anything else. Just click create dataset. Perfect. My dataset is created. Show of thumbs. How many of you got to complete this step? Raghavi, if you don't see the project, you should be seeing it in the Explorer pane. You should make sure your project is visible. Your project ID will be visible. If no project is selected here, then probably you wouldn't be seeing anything. So make sure you're actually having a project listed on the top, on the drop down, and then you would be able to see the project ID listed here in your Explorer pane. Not in the leftmost pane, that is just navigation menu. The Explorer pane will have your project ID. All right. So moving on, go to your code lab, scroll down. We are in step 4, create a BigQuery dataset and external connection. So we have created the dataset. Now what is left? We need to make this dataset, or we need to make BigQuery talk to Vertex AI, right? So we're going to create BigQuery connection that will make that external communication with a Vertex AI service, which has the models that we want to talk to. So how are we going to do that? In the Explorer pane, right to the right of the Explorer pane, you should see the add button, plus add. Click that. So you see 3 options there: local file, Google Cloud Storage, and connections to external data sources. Go ahead and click connections to external data sources, because you're going to BigQuery, Vertex AI is an external data source. So click that. And in connection type option, you should get a sliding pop-up like this, external data source pop-up. The first item is connection type. Click the drop down, scroll down. You should see Vertex AI, remote models, remote functions, and Big Lake cloud resource. Clearly, this is what we want, because we said that we want BigQuery to talk to Vertex AI. So choose that option, and connection ID. Don't type, and you can actually type whatever you want, but we want it to be easy for us to copy paste. So scroll down in step 4, in the same step in the code lab, point number 4. It says in the connection ID field, enter your connection name as Gemini-BQ-con. Copy that name and paste it in place of your connection. And remember, the location type we chose in dataset should be same as the location type you're choosing for the connection. So leave it as multi-region US and click create connection. My connection is successfully created in a few seconds. It's not yet created. Or is it? Is it the one? Gemini-BQ-con. Yeah, that is the one. It is created for me. Click that. So in the project, right below the project ID, right underneath it, you will see external connections as an item. Click that item, expand that item, and you would see the connection that you just created, Gemini-BQ-con. Click that, and you should see the last configuration info as service account ID. Just copy the service account ID and keep it handy. Copy this, keep it handy. Why? We have created the connection, but we have not given this connection the permission to talk to Vertex AI. There is a service account for this connection, but fine. But what am I doing with Vertex AI? That is not established, right? So we have to create that permission. But before that, show of thumbs, how many of you were successfully able to create the data set and yeah, perfect. Now moving on. Right click on the Google Cloud logo and create and click open link in new tab. We just want to create a new we want to go to IAM page. Let's create it in a new tab. The reason is I don't want to interrupt the BigQuery page. We want to write queries in the same view, so don't change anything. Just right click on Google Cloud logo and open link in new tab, which will open the Google Cloud console in another tab in the same window. Why? Because we want to navigate to another service, which is IAM, Identity and Access Management. So click the navigation menu, and you should see IAM and admin option under products. Just click IAM and admin. If you don't see that in the products list, just search in the search bar, search for IAM and admin. It will show up. Just click that. All right. In my case, it's already loading, so I'm going to let it load. There we go. You see, I'm able to see view by principles and view by roles, two tabs out of which view by principles is active, and all the principles that currently have different permissions are listed there. You should see grant access button. Click grant access button. And under new principles, there is an empty tab, right? Empty text box. Paste the service account ID, which you copied just now, and hit enter. Don't worry about just click that, just select that, just enter. Don't copy paste it twice, just paste it once and hit enter. Now it is listed here in new principles. What role I want it to have? Click the select a role drop down under assign roles. And in the filter by role or permission text box, type Vertex space AI in caps, Vertex in V caps, Vertex space AI space user. Right? So what we are select that Vertex AI user option. So basically what we're doing is we are using the service account as a principal, and we are assigning the role as Vertex AI user. So basically we are saying this connection should be able to talk to Vertex AI. Click save. Updating policy, and we are good. You can close this IAM page and come back to the BigQuery tab. Now you can also close this connection info query tab, query editor tab. Why? Because we are done with whatever we wanted to do with the connection from a permissions point of view is done. So now we can get started with looking at the actual data. Show of thumbs, how many of you completed this step? Mohit or anyone from the leads, could you help Paul with the steps in the code lab? He hasn't created the data set. That is correct, Paul. You have to click the three dots for creating data set. All right, perfect. So now what we'll do is we'll look at the data that we are going to deal with, right? We'll first take a look at what it looks like in the public data set. So go to your code lab, scroll further down. We are done with the fourth step. So go to fifth step, use case 1, which is remote model invocation. Set up remote model invocation. So for that, we need to create a table. And before creating the table, we want to look at what the what the public data set looks like, our Internet Archive books table. So in the step 1 of under step 5 in the code lab, you'll see step 1. And within step 1, you have this create or replace DDL, the data definition language statement. Copy this from the code lab, go to your BigQuery editor, paste it. Don't run the create table yet. Just run the inner query, the select query. Just select the select query part from select star from BigQuery public data dot gdelt underscore internet archive books dot 1905. 1905 is a year that we are choosing the books from, but technically there are a lot of books from so many years that were archived and stored in BigQuery. You'll be really surprised. The entire text of the book is available for you in this data. Imagine what wonders, what kind of prototypes you can build out of it, what kind of data you have access to with BigQuery, right? So several years books are available. Just take a look at it. All the books that were archived, you can play with it. You can do whatever use case you want. But anyway, just take a look at what the data looks like, right? Just run the innermost query, run it. I'm only running the select star from query. I haven't created the table yet. Why? Because I just want to show you all what the data looks like. Okay, so if you see right here, it is showing record ID, date, collection, source name, blah, 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 theme of the book, version 2 themes of the book, location, locations in the book, persons, names in the book, organizations, blah, blah, blah. Scroll, scroll, scroll. And if you go to the extreme right, you will see a field called, the last field called book meta underscore full text. So if you scroll down, you won't be able to see the entire text here. This is actually the entire text of the book. So yeah, this is just from one table. We have only limited it to 50. But when you're creating the table, change that 50 to just 5. Keep it at 5. It's enough for you to create a table with 5 records, because generative AI, because we are running a lot of sessions as part of Code Vipassana, we've got very low trust credits project link created. Don't worry about it. That just means it's a trial billing account. But when you're actually using your project billing account, or something that you're using in production, or if you're just doing it on a different occasion, or a different project's credits link, you wouldn't be facing any issue with invoking the generative AI APIs. But for us, we limit it to only 5 records, because this is a very low denomination billing account, right? So I have changed the limit from 50 to 5 in that create or replace statement. I'm going to run this DDL. DDL means data definition language. It means you're creating a table, or rather creating a schema in your database. All right, so now my books table has been created, create or replace table. Remember, the Gemini BQFN is the name that you gave to your data set. Books is the name that you're giving to your table. Select star from this is the publicly available BigQuery data set, and 1905 is the name of the table. BigQuery and hyphen public hyphen data is the project name. Gdelt underscore internet archive books is the dataset name, and 1905 is a table name. Now that the table is created, go ahead and run a simple select query to see if you can see the 5 rows. Select star from books and just run this. There we go. You should be able to see the 5 records that you just created. Show of thumbs, how many of you were able to create the table and add records? Okay. Okay, moving on. Now that we've created the table, we already noticed that we've created the data. Typically, when you create a table, there is a different syntax. You will mention the entire schema elements. You will provide the column names, the size of the column, and all that. That is when you're only creating the skeleton of the table, or the schema of the table. Here, what we're doing is we are creating it along with the data. So it automatically understands that it will adapt to the schema elements and the column size and data type of the fields that are there in your select query to the table that you're creating, right? So that is why we did not specify any of those. If you're wondering why is this not similar to the kind of create tables that I write or you write, that's probably because we are creating it based on an already existing table. Now, moving on, now that we have created the data set, we have created the connection, we've created the table, we've updated the records, sorry, created it with the records. The next step is to create a BigQuery model. So why are we creating this model? The model is already there. We are going to use Gemini 1.0 Pro. BigQuery also supports 1.5 Pro. So feel free to try it out at your own time. Today, we are going to use Gemini 1.0 Pro. Now, why are we creating another model here? It's not another model. Basically, it's a reference to the model that lives in Vertex AI with the remote connection that we created. If you notice, Gemini BQFN is a data set. Gemini underscore remote underscore model is the name of the model that you're choosing right now. It can be anything, but use the one that is there in the lab right now. Remote with connection. This is the connection name, Gemini under hyphen BQ hyphen con, which we just created. Options endpoint, it is referenced as Gemini hyphen Pro. Alternatively, you can also give the entire endpoint of the model, any model that you want to use, if it is not labeled as in a specific name. In this case, Gemini 1.0 Pro is already labeled as Gemini hyphen Pro. So you can in BigQuery. So you can directly use it like this. So copy this create model DDL, come back to your query tab, open another tab if you like, just run this query. Run this DDL. You don't have to change anything. Just check what you're doing, understand what we're doing. We're creating a remote model in BigQuery to reference Gemini 1.0 Pro from Vertex AI. You should immediately see successfully created model named Gemini remote model. That's it. You can go to model, but actually you wouldn't, there's nothing much you want to do there. It just gives some configuration parameters in the schema of your model. That's pretty much it. It has labels and features. All right. So that's pretty much it. Now going back to the code lab, what we want to do now that the model is created, data is there, everything is available, it's time we build our generative AI application, the database application. So which means what we are going to do here is we are going to write a prompt that will read the locations data. Remember, I showed the select query results for you, right? The 5 rows, or rather we saw the 50 rows from the publicly available data set. You saw a field named locations, which actually mentioned all the locations that are available, that are part of the book or where the book was published. I don't know what that location reference is, but we have the data. You can read about the data set in the data set metadata, which is there in BigQuery public data set, but that's not our focus today. Just know that there is a field called locations, which has some random combination of address data in it for each book that is available in the table. What we're going to ask Gemini to do is read that location, standardize the address location, and print a consolidated standardized address. That's all we want Gemini to do, right? So that is what we are going to do as part of the generative AI application. We are building an address standardizer application. So for that, we are just going to use a simple SQL query, select query. So copy this query, come to your BigQuery editor. You can actually run this model over with this select query, just paste it here. I'll explain this. I'll just zoom it a bit so you can see my screen. Select. So this is the, first let's go from the innermost query. The innermost query is where we have select dash from Gemini underscore BQ underscore FN dot books. So we are clear that we are going to take the data, the 5 rows that we inserted into the books table. So books table is the data source that we're going to use. What we want to do there is we are going to take the locations as the input data. But for what? Right? So here is the prompt. What is the prompt here? This is the statement that I've given. You can change it to whatever you want. Try out a different prompt if you like, but better to stick to this one because when you're submitting results in the application, it's easy for you to submit it with this result, right? So if you change it, it might differ, but I think it shouldn't validate your result based on the text. Try both. If it doesn't accept the first one, you can submit always the one that is there in the screenshot, right? Okay. So now what is there in the prompt here? It says you're a text summarizer and standardizer. From the following text that contains address locations, standardize and print one standardized consolidated address. You can actually instruct it saying that you're an expert in address standardizing. You can make the prompt more standard. You can make the prompt even return in JSON standards. I'm not doing any of that today. You can try that, but I'm just asking you to standardize it in text format. That's all, nothing else. All right. And model is the parameter where you're actually passing the remote model. You remember we created a DDL to a remote model that references Vertex AI using the connection we created. That is the model you're invoking here. And this is the prompt. And this is the table which is stored, which has the data that we want this generative insights done on. All right. And what is the last part that says struct through as flattened JSON output? Typically, the output that comes out of generative AI application when you're invoking the model has a lot of data. We just want that consolidated and we only want the response text. So that is exactly why we are actually we are not even taking only the response text. We are just flattening the JSON output. That's all. And we are printing the result here. This is the column. This is the result column of the LLM model of the generative AI model Gemini. And we are the alias name that we are giving to that is Gemini response. So basically what you'll see as a result of this query is Gemini response and the prompt input. All right, so you're ready to see the result. If you want, you can also see the locations, raw locations as output if you like. You can just choose that if it lets you. Yeah, you have to do that here as well. You have to select it in both places. I'll ping this query in chat in case you want to use mine, but feel free to use the one that is there in the code lab. You don't have to use this. All right, there we go. I got my result. I got standardized addresses. If you see, this is my location that is there in the raw data that is there in the database. See how messed up it is. How can not messed up, but it's clumsy. It's not consolidated. It's not standard. It has a lot of values. Whereas here, the standardized address has coordinates. It has additional address information. It has municipality. It has global municipality. Um, it has reasons why it has chosen a specific address. That's really amazing, right? It is explaining why it has included what it has included. It is explaining out of the available addresses, I have chosen Martian as a standardized address because it is the first address listed in the text. Not a smart way to do it, but it's okay. We didn't specify any condition, so it took the first one, which is amazing, right? How many of you got this result? Show of thumbs, please. That's nice. Perfect. So that is it for getting the generative AI response. Now it's so simple, right? You got the generative AI applications result. You got it right in place, which means right where your data resides. Now, let's say you want to build a web application on top of it. You can just quickly write a cloud function or any other application, any platform you want, and you can just invoke this. You can just connect it using, you can just directly connect it to BigQuery using APIs in BigQuery, or you can use the JDBC connectors, or if it's Java, or if some other connector, if it's any other programming language. And you can just use this, you can directly use this query to get consolidated results. All you have to do is just pass in the user search text. You can build real-time applications without going back and forth between the data and the generative AI model and writing multiple lines of code. If you're an analyst, or if you're strong in SQL, or if you like to do the heavy weight of doing the generative AI insights in the database, in some cases it's not even an option. Why? Because your analytics data probably resides in a data warehouse, and you would want to do all of your generative AI implementations in your database and just show that in a web application. So this is ideal for situations like that also, right? So this is what you have to submit for your result. So basically your result looks very similar to what you see in this step 3 screenshot right here, right? You see in my screen, right? This view is what what you're going to submit. You can just copy this and submit, or you can just submit the result that you have gotten. Either way is fine, but make sure you submit the result, because you've taken the effort of sitting through this entire session. You might as well submit the result and get notified by, you get the certification from GDG Cloud. And also you'll get you'll get a codelab completion badge. So that's definitely another advantage too. All right, so now that we've completed the first part, this is how you invoke remote model in BigQuery. You can call any remote model right here. Now, the second use case that we're going to discuss. At this point, you can just relax. You can just listen to me, do it at your own time. This is not part of your result submissions for today. But it is important. Why? Because a lot of times you will not just use the model out of the box. You will want to do a lot of additional, additional massaging of the data, or additional integrations to third party applications, or you may even want to take input from the user and then process it before sending it to the LLM, right? So you will want to write a cloud function and then pass it to BigQuery as a remote function. So that is what we're going to see right now. But before that, show of thumbs, how many of you are comfortably completed this? And let's move on to the next one. Show of thumbs, please. Questions asked. Questions in the chat. Lise, could you please help with Paul's question? Paul, if you're not able to see go to connection, that's fine. You will see the connection, external connection right here in the, so this is my BigQuery tab right here. If you see in the Explorer pane, right under your project, expand your project ID in BigQuery Explorer, expand the external connections. You should be able to see the connection that you just created. Click that and you can copy the service account directly from there. You don't need to, if go to connection, for me also the go to connection button did not come up right now. So if it doesn't come up, it's fine. Just go directly to the connection. Sounds good? Perfect. All right, so let me show you how to do the cloud functions part. You can just relax and listen in. We'll quickly finish it in 5-10 minutes, and then we'll have some Q&A, because this session was particularly kept in this in a way that we wanted to complete it sooner and have at least 10 minutes, because there were a lot of uh, questions about the credits links and other things over the weekend, and there was an outage, so there was a lot of issues. So I just wanted to make sure that we are all able to spend some time talking about that, and then we'll wind up at 9:30. All right. So for second one, the remote function implementation, the use case, like I said before, is we are comparing two images. We're comparing a test image with a baseline image, and we want Gemini 1.0 Pro Vision. We're using a different model here, Vision model, to compare the two images and tell us how far or how close is the test images from the baseline image, whether it is similar or not. For that, I'm going to create a Java Cloud function. To why I'm using a Java Cloud function is because I'm going to do some integrations or something additional on top of just using the model. If I'm just using the model out of the box, I can do this comparison directly in BigQuery, because BigQuery itself already, I told you in the beginning that it is able to store unstructured data as well, as references to the data that are stored in cloud storage. So you can directly call the model Vision model, and then you can directly do the comparison there. But that's not what we want to do. We are going to do the cloud functions part. So how to do that? In order to do that, we'll have to activate our Cloud Shell terminal. So how do I activate Cloud Shell terminal? So go to Google Cloud Console, clicking the Google, if you're done with the BigQuery part. If you're interested, you can follow along. If not, you can just listen along. Just click the Google Cloud logo, and you will see the Google Cloud Console over here. And in the top right corner, you should see right next to the search, you will see Gemini chat, open or close Gemini chat, AI chat button. And right next to that, you will see activate Cloud Shell button. Go ahead and click that. That will open your Cloud Shell terminal. So this is how you activate your Cloud Shell terminal. If it is the first time, it will ask you to enable API. Go ahead and enable the API. I'm going to open a new window, and I'm going to toggle between editor and terminal in one window, and I'm going to have the terminal open in the other one. So how do I toggle between editor and terminal? If you see right here, this is a terminal, but on the top right corner, the first icon that I see is Open Editor. Click that. So every time you activate Cloud Shell, Google Cloud provides you with an editor and terminal. Editor, so you can store, write, create projects, whatever you want to do. Editor is an editor. It's a code editor. It's very similar in look and feel to your Cloud Code Editor or VS Code Editor. It is also known as Cloud Code, this one. You can also call it as Cloud Shell Editor. And terminal, it is very similar to your shells and other terminals that you use to interact with your operating systems. Similarly, you will use Cloud Shell terminal to interact with Google Cloud Services and the projects that you have created using commands. So everything that we did in BigQuery today, if you remember the connection, the dataset creation, the connection creation, IAM permissions granting, all those things have multiple ways or multiple approaches to get those done. Today we did it through console, but ideally, in a production setup, you would do it programmatically, or you would do it through Terraform script, or you would write Cloud Shell scripts, Cloud Shell commands. So you can do it in one of those ways. So that is what Cloud Shell is used for. It allows you to interact with Google Cloud Services and the projects that you create. All right. So I'm going to close this because I have terminal open in another tab. Now, once you open Cloud Shell Editor, it gives me the option to open folder. If you don't see it, that's always fine. You can always go click here and go to file and then say open folder and land on your root folder. Just hit enter. And if you notice, it is initializing my root folder right now. Initializing Cloud Shell Editor to my root folder right now, right here. If you see, it will list all the projects that I already have. And in the taskbar, you should be able to see a couple of things, which if for some reason is not coming up. You should be able to see Gemini Code Assist, and also you should be able to see login to your, yeah, there we go. I see it right here. This is my status bar. If you see right here, the bottom part, I'm selecting something. So tell me if you're able to see it. On the right, in the bottom, extreme bottom, you should see the Gemini crossed out. Go ahead and click that. This will help you in assisting with your code. This will help you in answering technical questions. You can use it literally to write your entire, any application. If even if you don't know how to create a website, just enable this and just ask questions like, where do I start? I want to build I want to build a plain HTML page. I want to write JavaScript. I want to write CSS. It has to look beautiful. I want to call this cloud functions, or I want to call BigQuery. Start improvising. It will help you get there faster. It's asking me to authorize. When I click the project cloud code sign in, go ahead and sign in, right? And then click this part as well. It will sign in a bit. Let's give it a minute. I think it's asking me to authorize here. So I'm going to authorize. All right. So let's see if it is authorized and all set. Okay. So if you see right here, it has logged me into the current active Google Cloud project, which is Duet AIC. Okay. So it has already logged me into that project. And here, if you see the uh, Gemini icon, which was previously invalid, is now active. All right. Previously, it was just crossed out, inactive. Now it is active. And you see this left Google Cloud icon right here in the left side of the status bar, which has my active project. If you click in the navigation menu, if you click Explorer, you will see the project structure. But what do I want now? I want to create, like I said before, a cloud functions application that does a bunch of things. Basically, call the Vision Gemini 1.0 Pro Vision API and just do a bunch of things, right? So I'm going to click this in the taskbar on the left side. I'm going to click my project ID. It will open up the Cloud Code pop-up with a bunch of options. I'm going to choose New Application. And I'm going in this list in page 2, in the pop-up in page 2, you get what kind of application you want to choose. I've already told you I want Cloud Functions application, right? So I'm going to click that one. And then you have options of Node, Go, Java, Python. Does it mean you can only write Cloud Function in these 4? No. You these are languages where the template is made available for you. If there's a language which Cloud Function supports, you can, if you have the template on your own, you can just write it without going through this method. For these 4 languages, this is the most optimal way, because you will see that in a bit. I'll click Java Hello World and it'll ask for the project name. I'll just say, I think copy from the codelab. It says Gemini BQ function. I'm just going to copy the name of the project, Java project, paste it here and click OK. So if you see, it will automatically create the boilerplate code, all the standard placeholder for your basic template of Cloud Function for Java. It will preload everything and keep everything ready. You will only have to go in there, make a few changes and write your application. That's all. That's why for some languages it's actually easy. For some, you can write it. Doesn't mean that you cannot write your own application. You can completely ignore it and just click in the previous screen where you click the project name. You can just, here in the bottom, you can just click that and say new application. Don't create anything on your own. I know what I'm doing, so I'm going to create. You can do that as well. Okay. But I'm going to use a template because I'm comfortable in Java or Python. So I'll use one of those two. So I'm set. If you have some other, like if you want to do some other application, then yeah, definitely there are multiple ways to do it. So now I have, if you see, this is my project structure. As you can see right here, My launch.json is ready. It has an entry point to my project. It says the project, the cloud function is a generation 2, Gen 2 cloud function. Typically, you have Gen 1 and Gen 2. Gen 1 is no longer like we don't build Gen 1 cloud functions anymore. You build Gen 2 because it's more advanced. It has a lot more capacity, a lot more time, a lot more things that you would want to leverage. So go with Gen 2. Just a second, let me charge my laptop. Okay. What else? Function name. If you want, you can just go here, change the name of the class from hello world to whatever you want, right? I'm going to leave it as it is. Okay, because we're going to copy paste from my repository, my GitHub repo. So come back here. We already saw what the project structure is looking like. Now scroll down further. We want to add necessary dependencies. So right here, if you see, there is a pom.xml hyperlinked to my GitHub repository. Go there, copy the pom.xml from here. Why am I copying here? There is already a pom.xml generated for you. I'm going to add a few more dependencies. You can just add the ones that are missing or just copy and replace the whole thing. All right, there's not much difference. So you can just copy and replace the whole thing. If you notice what is new here is that in my GitHub repo, I have dependencies that reference Google Cloud Vertex AI and google.code.json. Why? Because I'm going to handle a lot of JSON features in my request and response parameters for the endpoint. And Vertex AI because I'm going to use Gemini. So I'm going to copy this as it is instead of just replacing stuff, and I'll replace the whole pom.xml. Save it. You don't have to save it, a lot of save, so don't worry about it. And then the main Java function. Click the hello world.java. Now what changes there? Go back to the code lab, see what it says in point 11 in step 6 of the code lab. Change the name of your class to something more meaningful. Yeah, we should have done that. Gemini BigQuery function.java. Right, I'm going to copy that. I'm going to right click the hello world.java, do a rename right here and paste the new name that I copied. And what I'm going to do is I'm going to replace the sample code that's generated there with the code from my repository. If you go to that Gemini BigQuery function.java here, I'm just going to copy the whole thing, come back here and paste it. So basically what I'll walk you through the code. So the first part, if you see the comment is generated right here, I use Gemini to generate it. I'm not going to lie. So what I have done right here, not the code, I meant the comment. If you use this code assist, of course you can, there's no harm in generating code also if you want. If you're smart enough to get the entire code generated by Gemini, then there's nothing like it. It makes your life easy, trust me. So I can just say generate appropriate and meaningful code comments for this class and hit enter. I'm just showing this is not related to the function cloud functions part. This is just related to how I generated these code comments. Code assist is working. It will give me the whole class with the corresponding code comments. If you see right here. In this case, I already have some comments, but it has added some more on top of it, right? Anyway, now coming back to this part, what this code does. It is actually a cloud function that uses Vertex AI Generative AI API to generate text responses to user prompts. The function takes a JSON object as input, which contains the prompt string and maximum number of responses to generate. Okay, yeah. So basically, this is just a cloud function that takes in a JSON response and generates text response in return. Now, what exactly is it comparing? If you scroll further down, the service method, this is mandatory because all cloud functions need to have a service method. If you see, it is invoking something called as calls. It is not invoking, basically it is expecting your request parameter to have calls in its JSON request. The calls field is important. Why? You cannot change this because that is how BigQuery operates. BigQuery expects your remote function to have the field name called calls in its request, and in its response there is a specific field that it will look for. It is called is it result? Replies. So these two are mandatory. If you're creating a cloud function exclusively for BigQuery, then these two are mandatory. Your input request should have the calls field, and your response should have the replies map. So these two are mandatory. You cannot change that because that's BigQuery's way of interacting with cloud functions or remote functions for that matter. All right. So this is a JSON array of array. So that's what all this is, input processing. I'm not going to go spend so much time explaining this class, but basically this will take in your request. I'll show what the request looks like. If you see the code lab, it shows exactly what the request looks like. Go to the code lab in step 6, scroll down. You see the requests right here in the data part. See, do you see that? It's an array of array and it has calls as the input variable. Okay, so that is a request. And this array contains, array of array contains two inputs, or two strings rather, two elements. The first one is the baseline image and second one is the test image. That's all. And the third element in that array of array is a prompt about the images to Gemini. This is where you actually pass your prompt saying that anything, the assistant on the left is helpful or gives more detail, blah, blah, blah. Just give whatever prompt you want, whatever you want Gemini to do with the images that you're sending. All right. So just send that as a request. Now we are not done yet. I'm just showing you what I'm doing here in the first part. There are better ways definitely to process it, to process the input JSON. Use your best programming skills to do that. I just did a rough programming right there to get the input request and then store it in a list. Right now what I'm doing is I'm invoking this validate method on the input. So what is validate doing? I'm taking this image URL of the baseline image and the URL of the test image and the prompt string as input. So these three are the request parameters that you're passing into this method, and I'm passing it to what model? Gemini Pro Vision. So I'm calling Gemini Pro Vision for my project, which I have to replace, and then the US Central 1 as the region. I haven't replaced this. Let me replace. Do it. AI hyphen, sorry, do it hyphen AI hyphen C. Okay. Okay. I don't know if I have to change anything else, but yeah, technically the best way to do all these things is using environment variables or secret parameters, not writing it in the code. But since it's a test application, I'm just going to use it this way. And then, yeah, so these are parameters. It tells that your temperature is set at 0.4, your top K is 32, top P is 1, which means you're setting the temperature, the creativity or the wildness of the response under 50%. And then you have top K, which is the number of tokens that you want the next possible response to be picked from, and the probability that you want your tokens to have at a bare minimum as the input parameters. Now I'm calling provision based on the configuration fields that I've passed in, and also based on the parameters that I'm passing in from the three input values. Right. So I'm taking the response, I'm processing it, I'm generating it to I'm sending it to a string called result, or res for that matter. I'm just printing that in the response. I'm printing that string result to a map which has replies as the field name, because that's what BigQuery expects. That's it. That's all this function does. Nothing much. Now, this read image file is to read the URL and convert that into an image. So that is what that does. Now, all that is done. There is a command that you execute to deploy this cloud function. So I'm going to just copy this. No, before that, I need to navigate into the folder by using cd Gemini-bq underscore function. So let me do that from Cloud Shell terminal. CD basically changes directory and takes you into that cloud function folder. And then I'm going to deploy this cloud function. All right, so I'm going to paste it right here. I'm not changing anything because I didn't think, I'm just using the source code as it is, except for the project name. So when I'm deploying, it is asking me, where do you want to, which region? I'm going to change, I'm going to provide the region code as 31, which is US Central 1. And then it'll take a few seconds. We don't have to wait till this deployment is done because it's almost time, but let's see if it completes deployment by the time we're done talking. All right. So once the function is deployed, you will get your URL generated like this. You have the region name, you have the project ID .cloudfunctions.net / the name of your function, right? And then you can test it by passing this thing directly from your Cloud Shell terminal. But the real objective for us in this application is to test it from BigQuery, not just from here, right? So what we'll do is we'll have to put the respective images in a cloud storage bucket. right? And then we have to, the test images are provided to you in the code lab. So feel free to use those test images, and the instructions are listed right there. You can create you can create a cloud storage bucket, you can push these images there, and then create an external table in BigQuery that actually stores these two, the images and the corresponding metadata in BigQuery. The images are stored in cloud storage and the corresponding metadata is stored in this external table. If you notice, it is not just create or replace table, it is create or replace external table. By looking at this keyword, BigQuery will know that this table's actual data resides in cloud storage. So that is why when you pass in the gsutil URI of the cloud storage, it will understand to pick the image files from the folder path that you have mentioned right here. And then there is just one DDL, which is create. Remember how we created the remote model statement by using create or replace model? Similarly, sorry, we did create or replace remote model. Similarly, here we'll create or replace function because it is a function that you wrote. You provide a function name. Of course, dataset is the same dataset that we created before. You provide a function name, and then you pass input parameters as baseline, test, and prompt for that function, returns string. And in here, you're using the connection that we created, the remote connection that we created, no? That one. And endpoint. This is where the real thing is. This is where you're passing your cloud functions endpoint that you got as a result of deploying it right here. Okay. So we'll have to look. I haven't probably changed one of the parameters. So the deployment, I wasn't looking to deploy this anyway, but I just wanted to walk you through the code. Feel free to make all the necessary changes there in the code so that your deployment is successful in one attempt, right? And then once the function is deployed, you will get an endpoint that looks very similar to this. You will only have to change your project ID. If you've chosen the right, the same region, which is US Central 1, replace this endpoint with your endpoint. And then once you deploy this, once you run this DDL, your remote function will be created. Now what is left? There's only one part, which is invoking the remote function in a select query, just like you invoke the remote model in a select query. Instead of calling the model, here you're calling the function which you just created. Select the function, right? And pass the inputs. You'll pass the baseline image, you'll pass the test image, and then you're passing the prompt. And my prompt here, funny enough, is you are an expert image validator who can respond with JSON result. Find two images here. The first one is a reference. The second one is a test. Compare the second image to see if the second image is similar to the first in terms of text present in the image. Respond only in JSON format with three attributes: similarity, similarity score, and difference. That's it. That's my prompt. And the result looks like this once I run this. I only have one in one row of, I only passed for one set of images. And the result is this. Similarity score is 98.75. Similarity, yes. And difference comment is that the images are almost identical except for the text. Um, I didn't, yeah, this is the image. If you see, this is the baseline image and this is the reference image. If you see, the text is in fact different, but they're both similar because in the sense that they're both Duet AI in Cloud Console screenshots. Only the text that the console has is different in each. So that's pretty much it. This is what we already discussed, the benefits and use cases of having generative AI close to your data and using a scalable data warehouse like BigQuery, and also how it allows you to do enhanced analytics. So pretty much covered everything that we wanted to in this session. Show of thumbs, how many of you were able to follow this? Perfect. So thanks everyone for staying through the end of the session. So just one quick thing, the last few steps that we completed right here, it's not for your result submission. Result submission is only in step 5. If you see what you see in my screen right now, the screenshot is what you have to submit for your result. Whatever you've implemented or the screenshot, you can submit either. That's your result. If you'd like to clean up, you can either delete the project or you can just delete the data set in BigQuery. But yeah, unless you yeah, this one doesn't take up any space, any credit from your account, so you can just leave it as it is. You don't have to delete the project for this session particularly. All right, so I'll pause here. I'll just open up for a couple of questions until 9:40 and then we can leave. I saw somebody's hand raised. Do you have a question? Sitaram? Anyone has a question? I'll just stop recording right here.